Good Monday, everyone, and welcome to Astronomy Daily, your go-to source for space and astronomy news. I'm Anna.
And I'm Avery. It's February 16th, 2026, and what a weekend it's been in space. We've got 6 stories for you today, starting with some very welcome news from low Earth orbit.
That's right. After more than a month of operating with a skeleton crew, the International Space Station is finally back to full strength. SpaceX's Crew 12 mission docked at the ISS on Saturday afternoon, Valentine's Day no less, bringing 4 fresh crew members to the orbiting laboratory.
And what a crew it is! We've got NASA astronauts Jessica Meyer and Jack Hathaway, ESA astronaut Sophie Adenot from France, and Roscosmos cosmonaut Andrei Fedyaev. They launched aboard a Falcon 9 rocket early on Friday the 13th, the first time NASA has ever launched a crewed mission on a Friday the 13th, by the way.
A lucky day after all. The Dragon capsule Freedom docked at the space-facing port of the Harmony module at 3:15 p.m. Eastern Time on Saturday. Commander Jessica Meyer radioed up as they approached, and Chris Williams, who'd been holding the fort with just 2 cosmonauts since mid-January, was clearly delighted to see them arrive.
You can understand why. The station had been down to just 3 crew members since January 15th, when Crew 11 departed a month ahead of schedule due to a medical issue with one of its astronauts. NASA hasn't identified which astronaut or given details, but it left the ISS short-staffed for a lot longer than anyone wanted.
Now, here's the interesting subplot to this mission. The original Crew 12 lineup was different. Russian cosmonaut Oleg Artemyev was originally assigned to the flight, but was abruptly removed back in December. Roscosmos officially said he was transitioning to other work, but reports from investigative journalists tell a rather different story.
Right. As we reported last week, according to The Insider, Artemyev was expelled from the United States after being accused of violating international traffic and arms regulations, ITAR as it's known. He was allegedly caught photographing SpaceX engines, documents, and other sensitive technologies with his phone. That's a serious allegation in the world of space cooperation.
Very serious indeed. It's a reminder that even in an era of international collaboration aboard the ISS, geopolitical tensions are never far from the surface. Fedyaev stepped in as the replacement, and the mission went ahead.
The Crew 12 team is expected to stay aboard through October, making this a slightly longer stint than the usual 6 months. Sophie Adenot has a particularly packed schedule. She's expected to take part in nearly 200 experiments, including testing a development version of the new EVA suit called Eurosuit, which was developed by French companies Spartan Space and Decathlon, along with the Institute of Space Medicine.
Testing spacesuits designed partly by the people who make hiking gear, I love that. All right, let's move to our second story, and it's the saga that just won't quit. Artemis 2 and its ongoing battle with hydrogen leaks.
Oh, this is becoming quite the drama. So here's where things stand. NASA conducted what they called a confidence test on February 12th, partially filling the SLS core stage's liquid hydrogen tank to check whether newly replaced seals in the fueling interface were doing their job.
And the result?
Mixed. They encountered a problem with ground support equipment that reduced the flow of hydrogen into the rocket. But the good news is that engineers were able to gather data at the critical interfaces, the exact points where the leak had occurred during the earlier wet dress rehearsal on February 2nd. And from what NASA Administrator Jared Isaacman said during the Crew 12 coverage, the early signs are cautiously encouraging.
He said they didn't see the same leaks at comparable periods during this test that they'd seen during the full wet dress rehearsal. That's progress, even if it's not a definitive green light yet.
For those catching up, here's the backstory. The first wet dress rehearsal ran from January 31st through February 3rd. They managed to fully load both SLS stages with cryogenic propellant and even got the countdown to the T-5 minute mark. But then the ground launch sequencer automatically stopped everything because of a spike in the hydrogen leak rate.
And these pesky hydrogen leaks are nothing new for the SLS program. They plagued Artemis 1 back in 2022, causing months of delays. The mission management team chair, John Honeycutt, admitted this latest round caught them off guard. Hydrogen is such a tiny molecule, it can escape through the smallest imperfection in the propellant system.
The February launch window has already been abandoned, and NASA's now targeting March for the earliest possible launch. Engineers worked through the weekend to purge lines, inspect equipment, and replace a filter suspected of causing the reduced flow. A second full wet dress rehearsal is expected before any launch attempt.
We'll keep following this one closely. Artemis 2, when it does fly, will send 4 astronauts, Reed Wiseman, Victor Glover, Christina Koch, and Canadian astronaut Jeremy Hansen, on a 10-day trip around the moon, the first crewed lunar flyby since the Apollo era.
Now, from the challenges of getting off our planet to the wonders of the outer solar system. Our third story is a real beauty, Anna.
Oh, I love this one. Saturn's tiny moon Enceladus, just 500 kilometers across, has been revealed as a giant electromagnetic powerhouse whose influence stretches over 500,000 kilometers through Saturn's space environment.
500,000 kilometers. That's more than 2,000 times the moon's own radius. An international team led by Lina Hadid from the Laboratoire de Plasmas in France analyzed 13 years of data from the Cassini spacecraft, and what they found is stunning.
So we all know Enceladus for its water geysers, those spectacular plumes erupting from the South Pole, but it turns out those geysers do a lot more than just spray water into space. The water vapor and dust become ionized, creating an electrically charged plasma that interacts with Saturn's magnetic field as it sweeps past.
And that interaction generates these structures called Alfvén wings. Think of them like electromagnetic vibrations traveling along a string, except the string is Saturn's magnetic field lines, and they're connecting this tiny moon to the giant planet's poles.
The researchers found that the primary Alfvén wing isn't just a simple structure. It's threaded by fine-scale filaments produced by turbulence in the plasma. These filaments help the waves bounce back and forth between Saturn's ionosphere and the plasma torus that encircles Enceladus's orbit. The result is this incredible lattice-like pattern of crisscrossing electromagnetic waves.
Across 4 different Cassini instruments, the team identified 36 separate crossings that showed these wave signatures. And here's the remarkable part. 13 of those crossings occurred far from any close flyby of Enceladus. The moon's electromagnetic reach is simply enormous.
Co-author Thomas Chust described Enceladus as a planetary-scale Alfvén wave generator, a moon just 500 kilometers wide, capable of influencing the magnetospheric environment on the scale of Saturn itself. The team says this has major implications for understanding how small bodies regulate energy flow in giant planetary magnetospheres.
And there's a forward-looking element too. The researchers say their findings highlight the importance of future missions to Enceladus, like the planned ESA orbiter and lander in the 2040s, carrying instruments specifically designed to study these electromagnetic interactions.
From Enceladus to interstellar space now, our fourth story takes us to the ongoing saga of 3I ATLS, the third interstellar object ever detected in our solar system.
And today, researchers from the Initiative for Interstellar Studies, I4IS, have published a fascinating new paper proposing how we might actually catch up with this cosmic visitor. The comet is heading away from us now, approaching Jupiter for its closest pass on March the 16th, before it leaves our solar system forever.
The challenge is obvious. By the time 3I ATLS was discovered in July 2025, it was already moving too fast for any direct intercept mission from Earth. Even the ESA's planned Comet interceptor, sitting ready at the Sun-Earth L2 point, wouldn't have been able to reach it.
So Adam Hibbard and colleagues at I4IS took a different approach. They're proposing what's called a Solar Oberth Manoeuvre. The idea is to launch a spacecraft in 2035 that would first swing past Jupiter for a gravity assist, then plunge close to the Sun, firing its engines at the closest approach to maximize the slingshot effect. This would hurl the probe out of the solar system fast enough to catch 3I ATLS.
The downside, a 50-year flight time. But the researchers argue it's worth it. Every interstellar object that passes through is a message in a bottle from another star system. The science return from a close-up study would be extraordinary.
And there have been earlier proposals too, including one that suggested NASA's Juno probe could be redirected from Jupiter orbit to intercept 3I ATLS. But with Juno low on fuel and having engine issues, that always seemed like a long shot.
3I ATLS remains one of the most fascinating objects to visit our solar system. Bigger and more active than either Oumuamua or Borisov, it's given us an unprecedented look at material from beyond our stellar neighborhood. Even if we can't catch it this time, studies like this are laying the groundwork for when the next interstellar visitor comes calling.
Now, let's turn our gaze back to our own star for story number 5. If you're an Aurora chaser, today might be worth keeping an eye on.
That's right. There's currently a G1 minor geomagnetic storm watch in effect for today, February 16th, and it's being driven by a combination of factors.
First, there's a huge trans-equatorial corona hole directly facing Earth right now, and it looks like an old friend. Observers believe it's the same corona hole we saw back in mid-January, having survived its transit across the far side of the Sun, and come back around for another pass. These corona holes act like solar wind lighthouses, sweeping Earth with fast solar wind roughly every 27 days as the Sun rotates.
On top of that, an M1.0 solar flare erupted from active region 4373 on February 13th, launching a coronal mass ejection that's expected to arrive at Earth right about now. If the CME interacts strongly with the coronal hole's high-speed stream, we could see conditions bump up to G2 moderate levels.
For our listeners at higher latitudes, think Northern Europe, Canada, and the northern tier US states, it's worth checking those Aurora apps tonight. Even at G1 levels, Aurora displays can be visible in Scotland, Scandinavia, and across the northern tier US states.
And with the Sun now in the declining phase of solar cycle 25, space weather experts say that while big explosive events may become less frequent, coronal holes can actually provide a steadier rhythm of minor to moderate storms. Aurora chasers shouldn't pack away their cameras just yet.
And finally, our sixth story is a quick one, but it shows just how relentless the pace of spaceflight has become.
SpaceX launched yet another Starlink mission in the early hours of this morning, the Starlink 6-103 mission, lifting off from Cape Canaveral's Space Launch Complex 40. It carried 29 Starlink V2 mini-satellites to low Earth orbit.
This was the 10th orbital flight from Cape Canaveral so far in 2026, and we're not even through February. The first stage booster, flying for its 10th time, successfully landed on the drone ship a shortfall of gravitas in the Atlantic.
10 flights for that booster. SpaceX continues to demonstrate the reliability and reusability of Falcon 9 at a pace that would have seemed extraordinary just a few years ago. Combined with the Crew 12 launch on Friday, SpaceX's 600th Falcon 9 flight. It's been quite the week for Hawthorne.
The 600th Falcon 9. That's genuinely remarkable when you think about it.
It really is. And that brings us to the end of today's episode of Astronomy Daily. Fixed stories covering human spaceflight, lunar ambitions, Saturnian science, interstellar visitors, space weather, and the unstoppable launch cadence of SpaceX.
If you've enjoyed today's show, please do leave us a review on your favorite podcast platform. It really helps new listeners find us. And follow us on social media at Astro Daily Pod for updates throughout the day.
You can also check out our full show notes and blog post at astronomydaily.io, where we've got links to all the sources and studies we've discussed today.
Until tomorrow, keep looking up.
Pull your eyes, everyone.